Welcome, everyone. Thank you very much. Hopefully, this is a good follow-up to Marive's talk. I'm going to be talking about knowledge bases and memory for agentic AI. But before I start, how many of you here are familiar with RAG? Hopefully, quite a few of you since last week. Great. How many of you here are familiar with vector databases? And the next one is going to be a different question. How many of you are a bit tired of hearing the word agents or agentic AI? Great. Okay. Hopefully, I can narrow it down to a simpler, a bit more simple definition of what agentic AI is. Before that, my name is Tuana. I work for a vector database called Weaviate, and a lot of this talk is going to be about the role of the vector databases in agentic AI. And I got the idea from my friend David yesterday, so I'm doing this little segment. I am from Istanbul, but I am half English, which is why I sound like this. I don't live in any of those places. I live in Amsterdam, and this is my first time at Vilnius. So that's a bit about myself. And what I'm going to be talking about is two new services or products, if you will, that we released recently at Weaviate. One of them is called the Query Agent, which I think is a great demonstration of using vector databases as knowledge bases for agentic AI. And I'm actually going to be talking about a different kind of memory, which I don't think you expect. And I'm going to be talking about that very briefly at the end with the personalization agent, which was the latest one we released. And I'm going to very loosely follow this agenda. So we're going to start by talking about what RAG is. Hopefully this is not going to be super new information for you all. And then I'm going to do my favorite segment about a little thing about the history of agentic AI, because I do think right now there's like a million definitions of what an agent is and what agentic AI is. Spoiler alert, agents is just not new. It feels like it's new. It's not new. People have been working on agentic ML, if you will, for a long time. But we've kind of adapted the meaning to current day LLMs. Then we'll have a bit of information about functions and tool calling. And hopefully, I have time for a quick demo. But if not, I've already shared the slides and the example code I created in the Discord channel for this room. So if we don't get the time, you still have the code. By the end of it, hopefully, we're going to build a Weaviate assistant that has access to two separate knowledge bases, and we'll have an agent that decides which one to use. And it's going to be the Weaviate documentation and GitHub issues. All right, so let's start by imagining a scenario. We have an application and we have this user, and she has the question, how can I use local Olama models with Weaviate? Now, in an ideal world, this user has the intelligence and the brains to say, oh, maybe I should go and look at Weaviate documentation. Maybe they also use a generative model to generate an answer for that. If they, however, have the question, are there any Olama-related issues reported to Weaviate? Maybe, again, this same user has the intelligence to make the decision that, oh, I should go along and check the GitHub issues, and maybe they generate an answer from that. So this is basically where RAG stems from. And I love doing this little segment in literally all of my talks, but this is the idea behind RAG. So this was me having a chat with ChatGPT 2 days ago. And I went ahead and asked the question, what time is Tuana's talk and what will she talk about? And I got an answer, which was wrong. It did use the internet to figure out some good resources for this question. The second paragraph is not even me. But technically, the model behind ChatGPT is doing the right thing. The model is trained to generate human language. We can't expect more. If I change the way I do this process, and here I've cheated because I've gone ahead and copy-pasted the PyCon Lithuania page on this talk, and I've augmented my prompt with not just my question as the user input, but this context and also an instruction. And it turns out when this model has the right context, which is trained to generate human language, it did produce the right answer. Obviously, I went ahead and found the knowledge base, found the context, copy-pasted it, I cheated my way, and this is not how the real world works. And this is where vector databases come in. Just for those who don't know what vector databases are, I'm not going to go into detail, but the idea is simple. Any human text language can be represented as a sequence of numbers that we call vectors. And the closer those sequences of numbers are to other sequences of numbers in vector space, the closer they are in meaning. And this is where vector search stems from. So if we have a user query, and we can maybe go to the next slide, and use an embedding model to embed that user query, we can then compare that embedding or vector to all of the other vectors in our vector database. And vector databases are designed to do this at scale and at speed. We can get it to extract the most relevant context for that specific question. And we then quite literally augment our prompt to the large language model, and then it has both the context and the user question to answer from. So we started to build these types of systems, and we learned a few things, in my view. During this time, we learned that language models do not know everything, but they do work remarkably well with a good instruction and the right context. And this is where we slowly start to move to what we call agentic AI in 2025. Because we also discovered that the instruction defines the task. So earlier you saw me give the instruction, answer the question based on the context. I could have very easily made that instruction summarize the following context. And slowly, people started to realize we can also change the instruction to say, you have the following resources, you have this question, plan out how you would answer the question. It doesn't know the answer, but it can plan how to get there. So in our little demo, that example might be our same user having the question, tell me how I can use Ollama models and let me know if there are any issues I should know of. With just RAG, the way this might work is that this user might have the idea or the intelligence to say, oh, I should go and look at both of these knowledge sources. I should maybe generate answers from both of these knowledge sources. Maybe they even then say, you know what, I've got two answers. Maybe I should combine them and generate a combined answer for both of those, like a concise one answer for my entire question. And this is where classic RAG of just instructing with one knowledge source hit a bit of a brick wall, because classic RAG is designed to access one knowledge base. And this is where I want to talk a bit about the history of agentic AI. And this is my personal view. I'm not saying this is exactly how it went down, but these are two papers that I feel like actually started to pave the way to what we now call agentic AI, which is large language models planning and reasoning on how to solve problems for us. One of them is a mouthful. I'm not going to read out the whole name, but it's pronounced Miracle Systems. And this one is a paper that highlights that your model is not responding in the correct way because it doesn't know what the correct thing is. It can work well if you connect the right knowledge bases to it. That's basically what it's highlighting. The second one is even more interesting, and it stands for Reason and Act. It's called REACT. And this one highlights a specific way of prompting the model that prompts it to think about the user input, reason about what it can do, generate an action based on that reasoning, and then actually getting something to perform that act, then following that up with observation and then going through this loop. And this is where we started to see agentic AI form. So our learning from all of this was that models can reason about which tools to run and that they can produce an output on how to run that tool. They don't have the inherent capability to run the tool, but they can tell you how to run the tool. So this is my definition of agents. And if I were to narrow it down in 2025, what we would call agentic AI, I would say that it's a system that includes a large language model capable of making decisions on your behalf. So remember that girl who was like saying, oh, I should go to GitHub issues and I should go to Weaviate docs, etc. The whole idea is, why don't we offload that burden of making the decision to the language model itself? The next thing I would say makes agentic AI is that it's a system that's capable of interacting with its environment, in quotes, so interacting with tools and knowledge bases that are available to it. And this is a very interesting discussion nowadays, again, in my view. I know it sounds awful, the executors of our will, but I couldn't figure out a better way to describe this. But do we want agentic AI to perform actions on our behalf? or do we want to use them as research assistants? And I think there's a discussion now in the AI community in itself. And what I'm going to be showing is definitely more the research assistant style of using agents. So how does that work? It works with a simple thing called function calling or tool calling. And what we now start to do, and you can imagine the context that I gave to my initial ChatGPT RAG application. Now we're actually changing the context that we provide to the model. And the context we're providing is names and descriptions of tools that are available to it alongside the inputs that it expects. So in my world, I might be providing two tools, one called Weaviate Docs, and I say useful for searching through Weaviate technical docs and blog articles. And the other one might be Weaviate GitHub, and I say useful for searching through GitHub issues. And both of these things expect a query in the form of a string. So if I now have the question, tell me how I can use Ollama models with Weaviate, also how many open issues are there about Ollama, my model might be able to say, okay, here's the context I have. These are the two tools I have, and I should now make a plan as to which one to use when, and then I can combine the answers from both of those tools to provide the final answer to the user. So that sounds great, and this is basically what we set out to build at Weaviate for Weaviate collections. So we were imagining an agent that can access all Weaviate collections, and again, Weaviate is a vector database. And it turns out that pure vector search is not the only way that people interact with vector databases. Because if we go back to this question, tell me how I can use Ollama models with Weaviate, that question could be answered with regular vector search, similarity search. But it turns out how many open issues are there about Ollama, things get a bit more complicated, because if you look closely, this is a maths problem. This is a counting problem. This is what we call an aggregation query. And the issue is that there are many vector databases out there, and each of them may implement their own way of querying the vector database. So it's actually quite difficult to just say plug and play. So what we decided to do was to configure our own agent that is prompted specifically with the type of queries that Weaviate expects. So you can imagine that we have two tools, both of which has access to any given collection in Weaviate. So our query agent is deciding whether the user query or queries, combined queries, requires regular search and produces the required Weaviate vector search query, or it decides to do aggregation and produces the required aggregation search query. And this is where, and I'm really happy that I actually do have time for this, I want to show you an example of what I built. So this is my Weaviate console. I think maybe it's a bit too small, but here you can see I have the GitHub issues doc collection, and I have the docs collection. And for example, I think I'm in the GitHub issues one here. It lists the issue state, it lists the description of the issue. We've already pre-computed the vectors. We were using a snowflake embedding model when we did this. And I have the same for documentation. Maybe let's not wait for that. Okay, yeah, we have the same for documentation where it tells us like it's got the chunk of that doc page, it's got the URL of that doc page, etc. Next, what we do is we install Weaviate agents. I've done this already. And we connect to these two collections. So we've got the issues collection and docs collection. And the next thing I want to highlight is, as I mentioned, normally you have a function that has a description. And what we've done is, instead of that, we're also additionally using the description of our collection. And this is extra context that our language model will have when deciding which collection to search through. So here I've printed out, this is way too small, maybe I can make it a bit bigger. Here I've printed out the description of the issues collection and the description of the docs collection. So a data set with Weaviate technical docs and blog, for example. So this will also be provided to the LLM when deciding which documentation to look through. We can also have a look at what the specific properties are in the issues and docs collections, but this is where the interesting stuff starts. Maybe I won't rerun these because I think I'll run out of time. So I have the query agent, and basically what I've done here is I've said you have access to the documentation and the GitHub issues. And what I can then do is run the query agent with a question. Can I use Ollama to generate answers? And then what we'll see is that the result will contain the specific queries that our agent chose to run on which collection it chose and which query it decided to run. So here we can see that there were no aggregations that it decided to do. This query does not require any aggregations. Decided that my query was Ollama answers. I'll take it. It's not the best, but okay. And you can see that it decided that it should run that specific search query on the docs collection. Now, if I ask, has anyone reported Weaviate issues about Ollama? Again, I've got an answer. And this time you can see that it decided to run, again, the search query, Weaviate issues about Ollama, in the GitHub issues collection. So these are the specific search queries that our agent is generating for Weaviate collections. We can also provide the previous context as context to my next question, which means that I can ask follow-up questions. So this time around, I had asked for Ollama issues, and when I ask, what about Mistral? I then get Mistral issues related to Weaviate because it has the context that my previous question was about GitHub issues. And I see that it decided to run that on the GitHub issues collection. This is the first aggregation example that I have. How many open issues are there? But this time you see that the agent decided that there's no need for any regular search query, but it did decide that it will count the open issues that mention Ollama, that have any word like Ollama in it, and so on. The other thing we can do, I think this is, the other thing we can do is configure the system prompt of our agent. And usually what this means is that we're basically changing the blueprint of how our agent is designed to react in any given scenario. So this is basically one of the first instructions that our agent gets that we can modify. This, I think, is probably not actually even a great example because, in my view, a lot of language models out there does this perfectly anyway. But what I've done here is I've basically instructed the agent that it is, in fact, a multilingual agent, and that even though the documents it has in its knowledge bases are English, I want it to respond in the user's incoming language. So that's what I've changed the instruction, the system prompt to say. And it works pretty well. I tried this out yesterday, so that was nice. All right, so far this was all about how agentic AI accesses different knowledge bases, and the fact that, or the point that, basically when we say agentic AI, we're offloading the burden of deciding where to look to a language model. Another thing we can use vector databases, or any database really, is a sort of memory for agentic AI. Now, when we say memory, a lot of the time people think about, oh, there's this conversation memory that I have with my agent, and I need to store that somehow. And we do use vector databases for this as well. So we store conversational history, we vectorize them, we store them in vector databases, and then the next time the user has a question, we see if anything similar had been discussed earlier. This is a way we use vector databases. But another thing we recently released is called the personalization agent, which is a very different idea of memory, if you ask me. So what the personalization agent does currently, you can think of it as more of a ranking system that makes use of a large language model, where the ranking and the retrieval is based on a persona, and a persona can be anything. So for example, we want a recipe recommender service, let's say. And I may have a persona, Tuana, and Tuana hates okra, but she loves shrimp and mangoes. And she's a fan of Thai cuisine, all true, by the way. So that's some information that the agent has about myself. And I also have past interactions that the system can keep track of as I interact with the application. And you can think of these interactions as, we call them persona interactions. They're weighted from -1 to 1, -1 indicating a negative sentiment, 1 indicating a positive sentiment. And we can keep track of which objects I had positive and negative sentiments towards. And slowly, as I interact with the system, I can create a separate collection, which is kind of a memory collection, a memory on Tuana's past interactions with the objects in my system. And now, when I go back to this application, as I use it, the agent has more and more context regarding which recipes I like, which recipes I don't like, and is able to re-rank recommendations, new recipes as they come up for me specifically. And with that, the demo code that I just showed and I didn't run because I thought I would run out of time is available to everyone. I've sent it in the Discord as well. So is this presentation. And you can try it out and let us know what you think. And with that, thank you very much. And I think I can take questions.
Warm applause. Yes, coming back. Okay, so coming up, questions in Discord as well. But if you have questions, you can just raise a hand, and we have a mic for that as well. So yeah, go ahead.
Hello. So thank you very much. You mentioned about multilingual model that you implemented and demonstrated, and you said it works quite well. So what languages have you tested?
I didn't use a multilingual model there, but what I did do in the background, my agent itself, it was using GPT-4o in this demo, I believe, which has many languages available to it. I don't know the exact number. I think they list it on the OpenAI docs. But what I did was I wasn't using a separate multilingual model, basically. I was using GPT-4o, and GPT-4o was instructed at the beginning that it will have all this access to different knowledge bases, and it can do search or aggregation on those different databases. But the primary instruction was your role is to always answer, even though your context is in English, always answer in the user's incoming language. And I tried it with French. It worked well. I tried it with Turkish. It worked well. And I think GPT-4o, I think, should work pretty well with the languages they say that they can support.
Well, the bottleneck for the Lithuanian language is really the retrieval part. And you also mentioned that based on the language, it searches in the particular databases, right?
Yeah.
So which means that, for example, the language which is smaller as Lithuanian, it will not have that strong retrieval part, right? And then
if this agent is doing its job correctly, and we could probably test it later on outside as well, it should translate your Lithuanian question to English before generating those search or aggregation search queries. I don't know if it will perfectly. We can see if it works out. But if it does the job correctly, those, hold on, let me go back here. This, for example, this aggregation or search that it decided to do, here you can see use Olama with Weaviate. This always should be in English if it's doing its job correctly. And if it's not, then we have to tune our agents. Yeah.
So which kind of means that it is using GPT model to translate into English, then does the search and does back translation.
Yeah,
Thank you.
Yeah.
Thank you so much. Next question. How aggregation functions are created? Is it possible to create and store new ones?
So far as I know, we have literally a library definition of different Weaviate accepted aggregation functions that the agent then uses as context as to how to create the next aggregation question. So yes, we could then, if needed, add more to that library of queries that it is able to create, if that makes sense.
Okay, we have running out of time, so only one question. So you mentioned that you are using Snowflake embeddings. Why not the fine-tuned embeddings for document retrieval?
Yeah, we could also use that. I'm only using Snowflake because we also just released the embedding service, which means that when I write the documents into Weaviate, and we only support Snowflake for now, when I write the documents to Weaviate, I don't have to do anything and it just generates it for me. but yes, we can.
Okay. Final question from Antas. Do you set any limits on how many function calls agent should be able to call?
Yes, we do. And in fact, this service is right now rate limited for that reason. It's a pretty substantial rate limit. But yes, and we also implement sort of loop breaks if the agent continuously decides to call a different function again and again. Yes.
Questions are coming in, but Tuana can answer in the Discord as well. So we have to change. Thank you so much. And please give
Thank you.
warm applause.